Okay, so we're moving into more alternating series tests, but now we're going to kind of mix it up. The alternating series test had that -1 inside of it, right? So we're going to see those a lot. But now we're going to talk about two different types of convergence. We have what's called an absolute convergence, which means that if you take the absolute value of your sum and that converges, well, then if you remove the absolute value, we're going to say that that converges absolutely. So really, think about the word absolute as like an absolute value. Also true that if the absolute value of our series diverges and without the absolute value it converges, then we're going to say it converges conditionally. For example, on that second part, when we talk about the telescoping series, we learned in the last section that this converges. But it does not converge. It does not converge for the absolute value of this. That would mean ignoring the -1, and that would be a typical telescoping series. Therefore, this actually only converges conditionally. So we have absolute convergence and conditional convergence. There is an example of conditional convergence because a telescoping series does not converge. But if you put a -1 to the k+1 inside of there, it will converge. Thus, the terminology is converges conditionally. Now, what's this other theorem say? So, if the absolute value of the series converges, then without the absolute value, that's also going to converge. Absolute convergence implies convergence. Equivalently, if without an absolute value on it, it diverges, just shoot. If you're having something that's oscillating back and forth and that doesn't converge, well, shoot, once they're all frickin' positive values, it's still not going to converge. That's kind of the game here. I don't know whether I'm making any sense. I'm just sitting in a room. Old man's yelling at sky or a computer. Can't wait to see y'all. All right. So here it is. If you have an infinite series, you have two choices. It diverges or it converges. And then from convergent things, we have absolute convergence. Powerful stuff. And then we have conditional convergence. Not quite as powerful. So those are our choices. So we're going to talk about absolute convergence as well as conditional convergence once we get to the end. So let's try a couple of problems. And I'm sure you're going to be great through this. So we want to determine whether one of the four things, whether we have divergence, absolute convergence, or conditional convergence. So let's try one out. All right, so we have k is equal to 1 up to infinity of -1 to the, I don't care if it's k+1 or 7 or anything. We're like, cool. Well, let's see. Does this converge? Does this converge? Does this absolutely converge? Does it diverge? So our first game is we're always going to just look at this. We're going to look at the absolute value of our a sub n. So our a sub n, or a sub k. We want the absolute value of it. So what I meant by that is I just took the -1 out of there. Took the -1 and just replaced it with a 1. We ignore the negatives. Have we done any work so far where you're dealing with that -1? No. And we won't for a while. And we're like, okay, cool. Well, the limit as k goes to actually, hold on. What's going on? This is 1 over k to the 1/2 power. By p series, this diverges. So does that mean that this diverges? No. All we've done here is we've just done this. Oh. Well, it sure as hell isn't absolute convergence. Now we need to figure out, is this conditional? Or does it just actually diverge? Because all we did was we showed the absolute value of it would not converge. Now we go back to what we did before in the last videos. We're like, okay, well, let's see if this thing is going to conditionally converge. You didn't know you were doing that before, and that's what's happening. So the two rules, right? We got to have that it's non-increasing. And again, we're only looking at the absolute value part. And yeah, that's true. That's 1 over a k. Yes, that's going to decrease. And now we want to know, does the limit as k goes to infinity of the absolute value of a sub k, does that equal 0? And if so, we will say that it converges conditionally. So we take the limit as k goes to infinity of 1 over k to the 1/2 power. That didn't take too much work. That goes to 0. Oh, therefore, this converges conditionally. Okay. So take the absolute value of the bad boy. Look, does it converge? If yes, boom, it converges absolutely. If the absolute value does not converge, you're like, okay, cool. Now I got to choose. Now I'm going to go back and use my alternating series test to see whether it will converge conditionally or maybe it just won't converge at all. All right. Next. Let's try another one. Same game. Same game. Not changing the game up. So we get -1 to the k plus 1 all over the square root of k cubed. All right, we got those three options again. Absolute convergence, conditional convergence, divergence. What are we going to get? So step 1, we're going to take this piece out. I'm going to call this some a sub k. I'm going to put an absolute value around it, which just means ignore the -1. So you're just going to replace it with a positive 1. I also want to write this a little bit different, and that's k to the 3/2 power. Remember, the power is the numerator. The root number is the denominator. Well, shoot, by p series, I was going to write p. By p series, this converges. So since the absolute value of the problem converges, well, come on, man. Come on, man. Come on, man. Then this converges absolutely. So if we can take the absolute value, find it converges, well, boom, we're done. So this converges absolutely. Really, meaning it's just like, hey, when you take the absolute value, it converges. Just don't make that word out to be more than it is. Let's try another. Let's just keep knocking these bad boys out. Good thing you can possibly send me back or something like that. So let's look at from k equals 1 up to infinity. And let's do sine of k over k squared. And let's see if this is going to converge, diverge, conditionally, absolutely. I don't know what's going on. So, you're like, but where's the -1? Well, there is a -1 in here. There is a negative. You just don't see it. Did you know that sine changes sign? Yeah, so it's not strictly a like positive, negative, positive, negative. It actually goes positive, 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 negative, negative, negative. So the alternating series test doesn't apply. It's not the same thing. Even though negatives pop in, it doesn't go back and forth. It doesn't oscillate between positive and negative. Therefore, AST does not apply. But could you still solve this? 100% you could. So we're not using the absolute or the alternating series test here, but we're like, hey, I can still look and see if this thing goes. We're going to take the absolute value. Sine of k over k squared. Oh, dude, I forgot to put my absolute value on the k squared. It's always positive. Why the hell would you put an absolute value on it? So what we're actually going to use is the comparison test. And say that this is less than or equal to, what's the largest sine can ever be? 1. So if we can actually go through and look and be like, well, what would happen with this sum? Would this sum converge? Because it's bigger than this one. It's bigger than that one. Well, yeah, it converges by p-series. Oh. So the absolute value converges? Therefore, I don't need to do any more freaking work. This converges absolutely. And let's just do one more and we'll finish this thing up. All right. Now what about this one? What about the sum from k equals 1 up to infinity of -1 to the k? Oh no, there's not a k plus 1. Who cares? Doesn't make any difference. K over k plus 1. Well, as per usual, we're going to be like, well, take your a sub k, take the absolute value, which means just ignore the gosh darn negative. Take that off. And we want to look at this and see, like, hey, does that converge? Well, if you were to take the limit as k went to infinity, you know, the limit of this thing, that's a 1 in front of that k, and that's a 1 in front of that k. The degree of the top is 1. The degree of the bottom is 1. So we just look at the leading coefficient, so this goes to 1, which does not equal 0. Therefore, this diverges by the divergence test. Boom. Done. Over. That thing's just not freaking working. It's going to 1. Nah. It oscillates and diverges. We mollo. Oh, there we have it. There we have it. There was 4 problems. Just trying to show you the game. One more time going back to it. Absolute and conditional convergence. Knowing the difference between the two. Big deal, because I will ask you on things. Hey, if it's going to converge absolutely or whether it will converge conditionally, it'll be up to you to understand the differences between the two. Once again, it's a very short section because at the end, we're going to take it all, we're going to put it all together. All these ones with tests, 10.4 through 10.7 are going to be a bunch of different tests. So we've learned divergence and integral. We've learned our limit comparison test, our comparison test. We just got our alternating series test, and in 10.7, we're going to do ratio and root tests. Then in 10.8, we're going to put it all together. And it's going to be up to you to really kind of see what types of problems are which. And then I'll explain the game for your exam. Okie doke. I'll see you in the next.